Okay, hello, welcome or welcome back. Okay, there's some echo. Give me a second to adjust, but in the meantime, uh, welcome. Uh, it is a slight change of the usual schedule that I'm doing junior after senior. And that is because I'm making the potentially wrong assumption that you are less likely to be doing open tomorrow if you took junior today, as compared to those who are doing senior. So if that is a wrong assumption, I am sorry, but this is the fastest I could prep the junior one after the senior one, and also um, rest my voice and stretch my limbs a little bit. Now, I want to say that this is a very interesting paper. Sounds like euphemism and a meme, but also when I say interesting, it's because after the paper, of course, I get messages from both junior and senior students. For senior, it was kind of quite consensus. That was horrible. For junior, I had like a very significant portion that said that was horrible, and another very significant portion that said that was really easy. And so I took a while to try to figure out what is going on, and I think I understand what is going on because this is interesting uh, as a paper. Now, of course, some of your friends are a bit traumatized and do not feel like showing up. Please feel free to invite them to join in because, well, once we explain it, I guess, unlike maybe a lot of the other papers, you will probably still agree that if you thought it was hard, you'll still think it's hard. If you thought it was easy, you'll still think it's easy. So I'm not going to be here and trying to tell you that, oh, actually it's easy, it's just something was wrong with your brain. I am not going to say that. The reason is that this does not look like SMO junior paper. Okay, so this, it looks like an AMC paper, like one third AMC 10, one third SMO junior, and like one third of like, I don't know, maybe you can say like, let's say one of your primary school Olympiads, like your RMO or APM or PS or something like that. That's what it gave me the vibes of. And therefore, it's weird. It's not like the usual SMO junior. But if you were to actually look at the um, questions, solutions, they're not long. They're just using topics that don't normally show up that much in the SMO Junior. So if you practice very extensively using the past SMO Juniors, using my videos, I hope they were useful in some way. But if that was all you used, then perhaps I owe you a slight apology that it is not a guarantee that one year will look like the other. And you should not assume that. But also, I should make that very clear right now. Therefore, next year may go back to a pile of algebra again, but this year's one is definitely a little bit more unusual. Now, I will, just like the senior one, talk about cutoffs because this is what you're asking about, and I am not going to delay it further. I feel like as if many of you are going to have heard from, let's say, your friends who have said that it is easy and have somehow scored a lot, and they're not lying. But the number of people who scored a lot is going to be quite a lot fewer than the length of the round 2 list. Meaning that I feel like the top 30 students will score really well, but I feel the cutoff will go down. Now, those can be both true at the same time because the number of people who are going to be familiar with the kinds of questions that we have in this SMO junior paper will find them easy, but the number of people will probably be only at most at 30 to 50 students, whereas the round 2 name list is over 100 people. So That means that you don't have to worry about the top 30 to 50 people when it comes to the round 2 cutoff, and certainly not for the silver, bronze, and honorable mention. However, if you're aiming for a gold, you should assume that anyone who's aiming for a gold has probably got 20. Okay, so for round 1, this is what I will say is my assessment for this junior paper. I think I also did share, and so there's no secret about the paper that yeah. So this is something that I don't get to see in advance, but because I was helping with the SMO conduct this year, so I managed to see it a little bit earlier than well, last year. I mean, last year is like I'll just see it straight at like 1 p.m. right? So I got to see it earlier than that, and so the junior paper, if I approach it as a student, sorry, if I approach it as a student and not as a teacher, meaning that I will make whatever assumptions, I'll make whatever guesses, I think it can be quite easy to find lots of shortcuts. And so I'll talk about a lot of those things here. But to write out the solutions in full, some of them are a little bit longer. So that's the other aspect, right? There are lots of sneaky tricks which I will mention as we go along. Okay, so let's get to the questions. We will split up the review into about 3 parts, so there'll be 2 breaks in between for you to ask some questions and for me to rest my voice. My cutoffs are not definitive because the number of people who get into round 2 is not a fixed number. The SMS can decide to have more people or fewer people, and they do not need to adhere to any fixed standard. And therefore, obviously, I'm only assuming that it is the same range as last time. If they suddenly allow 200 people into round 2, congratulations, all of this will drop. So we will see. Okay, question 1. Find the shaded area. Is this hard? Well, this is the start of many questions that I would say have not been traditionally in the last 5-6 years of the SMO Junior, but you would see them in lots of places. So it is 2 congruent semicircles. The radius is 2. And so if let's say that I drew this here, this is an equilateral triangle. They're all 2 cm because they are all radii of your semicircles. That means that if I take this portion, that's 1/6 of a circle. And if I take this tiny slice here, this is actually 2/3 pi. And then another 2/3 pi minus the area of the triangle. The area of the triangle, because it's an equilateral triangle, I can always just split it in half. This will be 1, and this by Pythagoras would be √3. And so the area is half times 2 times square root 3 is equal to square root 3. So that little bit is 2/3 pi minus square root 3. There was already 2/3 pi from one of the wedges. So you get 4/3 pi minus square root 3. Now, I would say that this is very easy to guess because you can just estimate the area. So if let's say that you can't solve this, and this is a running theme of this paper also, there are so many gimmicks that you can use to get the answer. So for the first one, let's say you say that it's a bit more than this. This pi is about 3, lousy estimate. This wedge is therefore about 2, therefore your answer should be 2 point a little bit. And you can just estimate that your pi is around 3, and square root 3 is about 1 point something, 1.7. And you'll be able to just estimate that this is 2 point something, but everything else is pretty far away. except that you know it's not 2/3 pi because 2/3 pi is just a wedge. So it is pretty easy to guess by estimation. Right? I'm going to mention and acknowledge every loophole that I can find in this paper. But obviously, I will also mention the intended solution. Okay, question 2. You have got 6 points on a number line. M is the midpoint of AB, N is the midpoint of BC, and O is the midpoint of AC. So what I will do is that if it's the number line, you can just assign a number and you can assume that O is actually 0. Right? Because it's on the real number line, you can just slide it over that O is at the 0 mark. This is C, but because O is the midpoint of AC, I'll call this minus C. Right? So don't just call it A, B, C, then all you've done is just create letters of the alphabet. B can be anywhere because B is not a midpoint, so I'll just call that B. And then now I will just pause and look at the length. Okay, maybe I'll just write down Cn first, because that is now C minus B over 2. Now OM, M is the midpoint of AB, means that this is the average of B and minus C. The gap is also going to be 0 minus this is C minus B over 2. So they are the same. Okay, this is a proper method. If you want to guess it, you can. You can just sort of select weird enough numbers that coincidences are unlikely. Because when they say which of these is correct, to guess, you can kind of just pick 2 different examples, because if these 3, one is less, one is equal, one is greater than, then, well, they can't all be true at the same time. So you can just test some values, like let's say C is 2 and minus 2, and then like pick B to be something a bit random, like 0.4 or something, just so that the numbers are a little bit more randomly distributed, and then we see what we get. Right? Like this one is 0.8, this is 0.80. That's pretty coincidental. So you can assume numbers in order to guess. But I've shown the intended method as well. Now, question 3 is definitely the most difficult, like, of the front section, I would say, which you may not actually feel that because this looks like kind of a linear equation, but the floor function is just quite a nuisance. And so what I will say for question 3 is that if you want to kind of guess and check, you need to make sure that you have a list to check from. Now, floor function means round down, right? So if let's say you, by the way, for junior paper, they forgot to mention what this is. So if you've seen the past papers, you've seen this floor, but the floor just means round down. Not round to the nearest integer, round down. And so what I would do is that I kind of want to list out not the values of x, because x doesn't have to be an integer. I want to list out the values of this. But then I realized that I don't know where to start listing, right? Because I don't even have an estimate. And so if I would like to make that a bit neater, I would say that, well, the floor of this is this, means that this must be an integer. Because you round down to an integer and you got 7x minus 31 over 2. So we can just let 7x minus 31 over 2 be n. To remind ourselves it's an integer, I use n. And now I can make x the subject and write this thing in terms of n. So x is 2n plus 31 over 7. And 5x minus 2, just multiply the top and bottom by 7 to clean up that nested fraction. Okay, so now what I have is the equation 10n plus 141 over 21 equals to n. Now you might say that that is a lot of work that achieves almost nothing, right? Because this only looks slightly better than before. The difference is now I can list, but also I can estimate before I list. Means that I'm not going to just start listing randomly, right? N is an integer. I'm not going to try, okay, does n equals to 0 work? Does n equals to 1 work? Does n equals to... That may take a while. Instead, I can say that, well, this also means that it's quite close to n. Because floor means round up. So I can use this to get my starting guess and I work from there. Okay, so it means that I'm going to start from n is around 13. I'll start from 13, and then I will adjust from there if 13 doesn't work. Okay, so if n equals to 13, 271 over 21, rounded down, this unfortunately doesn't work. Okay, so up to you. Do you want to go up or down? But because my estimate here was n is actually 12 point something, so I will go down to 12 and try. You've done the calculation once. This is just reducing it by 10 over 21. So this works. And then this also works. So great. I have got n is 11 or 12. And I can substitute back in for x. So the first one will give you 53 over 7. The second one, 55 over 7. And when you sum up the two solutions, that's 15 and 37. So floor it one last time to get the sum of the two solutions. Whenever the question tells you the number of solutions, it may be a sign that actually it's not that easy to solve. You're just supposed to find two solutions. You may not actually need to like confirm that that is all. Yeah, so I think this is weirdly difficult. So when I tried the paper, like this morning, of course informally, but when I'm like looking at the paper, I kind of straight away skip this question because I'm like, I will need to sit down and write it properly because a lot of them is sort of like I'm doing it not 100% focusing on the question, right? I mean, that's your job. That's not my job in the morning. My job now is to focus on the question. By the time I just look at it, I'm like, I don't feel like doing this. So all of you also definitely have your own choices. Feel free to skip questions, right? And don't assume they're in order of difficulty, especially not the multiple choice being guaranteed the 5 easiest questions. That is very, very untrue, especially this year. Okay. Question 4. I said the multiple choice are not the easiest questions, and that is certainly true. However, you should still use the multiple choice options. Like, if the comparison is which of these is always correct, you should definitely again look at this block here, and to solve it properly, just take the difference because this is saying which is bigger, right? So you can just take P minus Q and check whether is it positive, negative, or zero. Another reason why I want to do that is because of the fact that I see 8 and 7, which add up to 15. So this is one of those things that you often want to do, right? Look and stare at the numbers with a great deal of suspicion. Okay, so P minus Q. Now, this is going to be a quadratic, we know. It's actually a nice quadratic because this plus this is just 8. Okay. Now, to check whether this is always positive or always negative, well, it's definitely not always positive. So to check whether this is also not always 0. So is it always negative? You complete the square. Right, so completing the square, this coefficient is 1, so you divide by 2. You end up with, you return 1/4, and this is indeed always negative. So that means option B is correct. If you are not sure again how to solve it properly, then try some values. I mean, that just try A equals to 0. You get P equals to -1, Q equals to 0, so you can already like eliminate three options, right? And then after that, you just like try, like, let's say A equals to, I don't know, 15 if you don't want to deal with the fraction. And then you just sort of see that, okay, it kind of looks like P is less than Q. Now, all of these I'm mentioning as alternative things that give you like a 60-70% chance of success, but obviously that doesn't replace the full intended solution. But in a paper where some of you found it very difficult, I'm sure you agree that many of these marks will be very valuable, and that's why I'm going to keep on talking about them throughout. All of these small little ways that you can scrape out a few more marks. Doesn't work for round 2, but for round 1, I will mention all of these things. Okay. Now, probability. Another thing that is not so frequently seen in the SMO Junior. I feel like as if I have actually said this question in one of my classes, right? Because I picked, instead of A, B, I think I had A, B, and C and a 3-digit number instead of a random die. There's a random 3-digit number. It is not guessable, this one, because you do need to know that your condition for 2 distinct real roots is your discriminant being positive. And the discriminant, if we don't get confused by the position of A, B, and C, in this case is A squared minus 4B. So this is your condition, and we are asking for the probability of this. Probability questions are only difficult if you cannot list them or if the list is too long. This is not very difficult to list because a die is rolled twice. There are 36 possibilities, right? 6 times 6. And it is quite easy to just find which ones they are. Just check, okay, A equals to 1. Well, let's rearrange this to 4B is less than A squared. A equals to 1. 4B is less than 1. Nothing. A equals to 2. 4B is less than 4. Still nothing. A equals to 3. 4B is less than 9, so B is 1 or 2. A is 4. 4B is less than 16. 1, 2, 3. If A equals to 5, 4B is less than 25. That's just everything. And for 6 also everything. And so you just count. There are 2, 3, 6, 6 there. Total of 17 cases. So your probability is 17 out of 36. Listing is not a bad thing unless you don't know how long the list is going to be or if everything in the list is going to take you 1 minute to check. If everything in the list just takes you 10 seconds to check, then just list. Okay, so this is multiple choice. Not the easiest multiple choice, but certainly not the most conventional multiple choice section is how I would characterize it. This is also a point where I guess I would say since this is the June and the SMO is in June, it's 1 year later. If you're watching this in 2026, it's maybe 2 days later, but otherwise it's 1 year later. Do take part in the AMCs, right? The American Math Contest. I alluded to it earlier. It is not necessarily going to be something that you can do amazingly in if you're doing junior right now. Like for Sec 1, you'll find it quite difficult. But it will give you a lot of exposure to the types of questions that don't usually appear in the SMO. And you are doing Olympiads because you like math to some extent, right? So we want to learn as much math as we can. There are a few old videos on AMCs on my channel, but not as much, honestly. The questions are quite easy to find. Just Google it and you can find a lot of the past AMC problems for your own practice and your own learning as well. Okay, we won't go up to question 10, unlike the senior one, because the first 10 are not like unilaterally straightforward. This is a minus. Okay, let me change that. And let me just line break it so it's easier to see. Okay, so question 6 is an absolute value inequality. This is just technical, but not actually very hard. The way that we handle absolute value inequalities is just to split into cases based on, because we know absolute value, right? If x is greater than 0, then the absolute value is itself. If it is less than 0, then it will be negative x, which sounds confusing, but this is just saying the absolute value of, let's say, negative 3 is 3, right? And how do you get 3? By negating the negative 3. How do you get the negative to be positive? By negating it again. So that's not saying that the absolute value is negative. Now, based on this, therefore, I can say that if n is 1 already, these are both non-negative, right? So if n is greater than or equals to 1, this is doing nothing. So we can solve this as a simple linear inequality. Oh, that doesn't work, right? N is positive. So no positive integers and work. But the question doesn't say positive. It says integer. So n can be 0 and can be negative. Now, I'll just do n equals to 0 separately, because when n is 0 here, this one is, we can just see, right? This is 4. This is 5 times absolute value of negative 1, which is 1. 0 works. I split off 0 because, first of all, my condolences if you forgot 0 and made the careless mistake. But secondly, because once n is less than 0, then this one also becomes negative and I can flip them both at the same time. Okay, I draw extra brackets to avoid any confusion. I know that my handwriting is not the best on a writing pad. It is also not the best even if it's not on a writing pad. Okay, so expand this. And you will end up with, move this over is n, move this over is negative 9. So n is greater than or equals to negative 9. That just means that n can be negative 1 all the way to negative 9. Or 0. So there are 10 numbers. This is more technical, meaning that you have to be aware that the way of handling this is to flip the sign when the thing becomes negative, split into different ranges of your intervals. Because if you were to try to list again, we don't know where to start and where to end. So this one, listing is not going to go so well. Okay, question 7. This is a quite common question for like primary school style Olympiads. If you assume that it's a square. Now this is the assumption thing again that I'm mentioning you can do. But it will not really change the solution too much, so I'm going to just stretch it back to its intended proportions. You can assume it's a square. If the question doesn't say otherwise, you're like, but the area is 24. No one said the length has to be integer, right? We only care about ratios of area. So if it helps you to assume it's a square, assume it's a square. If it helps you to assume that the lengths, I don't know, are 4 and 6, then by all means assume they're 4 and 6, and like 3 and 3, 2 and 2. Assume whatever you want if the question doesn't seem to give you enough information, and your answer will be correct. However, I will just state what I think the most efficient solution is, irregardless of the assumptions, which is that if you chop it like this, area of the rectangle is 24, right? So this part is 12. And for this part, if I were to draw this line here, I can say that this area, and this area are all equal to each other. This is the property that comes when you connect the two midpoints. This thing is known as the centroid. But it is also easy to understand as just that the ratio of this yellow area to the black area is precisely AE to EB, which is 1:1. And the ratio of this yellow area to the blue area is this to this, which is also 1:1. Okay, and so therefore this other 12 gets split into 3 parts. If you bear with me for a second, I will just explain this bit because I think it's a very commonly asked question that if I don't say it, some of you are just thinking in your mind, is this supposed to be obvious? But I don't understand why. So ratio of areas, right? If this is, let's say, A to B, we know that this to this, the ratio is A to B. The area, because they're the same height. Now, if I were to draw in a smaller portion, this to this is also A to B. And so if the whole thing is A to B and this fraction part here is A to B, then that also implies that this top portion is in the ratio A to B, right? Which is what I'm using here, except that A and B is just 1:1. Yeah, so if assuming the length will have helped you, then you can do that. But this thing is the most efficient way regardless. Okay, we'll do one more question, and then we will take our first break because there's a lot of you who are bugging to ask some stuff. Okay, so question 8, actually, hang on a second. The funny thing is that 8 and 9 are kind of linked. Okay, but let's do 8 and 9. In fact, let's do 9 before we do 8. I normally go in order, but this is just like too almost like perfect a setup if I do it in the reverse order. So I'll do 9 first. The information here are all just random numbers, except that they tell you it's an integer value. And also, I guess, technically they told you that the same total amount, which means that they have the same number of um, students, right? Because they have the same total and the average was raised by each of the classes, so same number of students. But that's not like the main thing that I want to highlight from here. The main thing I want to highlight is that the information is in integer. More than 30, you'll see why later, but the information is in integer. And it basically means that you want to divide by b plus 11, which is supposed to be the same as g plus 9. Now you could let b plus 11 equals to g plus 9, substitute it in, and then do it like a single variable thing. But this does give the nice opportunity to talk about what is known in the American contest as Simon's favorite factorizing trick. Who's Simon? I don't know. I never found out. Simon's favorite factorizing trick. I like to just call it completing the factorization, but it's basically just factorized by grouping. Even if it can't be factorized, never mind. We just sort of force it to happen by taking the same factor out a second time and adjusting by whatever adjustment needs to make, right? So I took 99, I'm left with 46, and I can therefore factorize it. Now, this is what is known as Simon's favorite factorizing trick for some unknown reason, but for a long time. Which in our case here, because it's b plus 11 and g plus 9, this is very convenient. It's just going to tell you that b plus 11 and g plus 9 must both be factors of this, which is then just of 46. It needs to be big enough. So if they are equal to 23, then your x would be 23 times 23 plus 46 over 23, which is too small. So it just turns out that they have to be 46, which is a class size that could only be thought of by an NUS professor who thinks that class sizes in a school can have 46 students. Right. Head is blocking it, I think. Yeah, so 47 instead. Now, this is the same thing that happens in question A, because it's still positive integer. So to continue on this discussion, but we're going backwards, because for that one, it's kind of like because you are dividing by b plus 11 and g plus 9, it makes sense to do this grouping. You see 9 and 11. So now I'm just saying that actually this Simon's favorite factorizing trick is quite a general tool that we use whenever they are integers. The reason is that I have more flexibility with my factorization. Has anyone actually done a quadratic equation like this? X squared minus 5x minus 8 equals to 0. Then you say, okay, x squared minus 5x equals to 8. X minus 5 equals to... This is not how you solve quadratic equations, right? Because x is not an integer, this is not going to work. X is going to be whatever ugly thing you get from the quadratic formula / completing the square. But when they tell you it's integers, I'm okay with this. I'm okay with having a number on the other side. So I take the first two, I do that grouping thing, and again, I force the factorization. I've borrowed 9 times 9, which is 81, so 101 appears on the other side, and lo and behold, this is actually useful because when they're working with integers, it's a number theory question. I can say 101 is prime. And if 101 is prime, then they are 1 and 101. And so, or vice versa, doesn't matter. So if I just take x is 10 and y is 110. So compute this and you get 12200, which is this issue that sometimes happens for the SMO, right? The same year can have 2 or 3 questions with that same idea that can cause a big swing in your score. There is nothing much I can do to prevent that from happening. All I would say is that you don't want to leave any topic completely untouched. Like I hate geometry, I hate number theory, and completely don't touch it, just because there can suddenly be a huge stack of questions all in that topic. That's just the practical implication of this phenomenon. Okay, now, so this is actually at the end of your second page of the questions, right, in the actual paper. So question 8 and 9, we will take a quick 5-minute break for me to get a bit of water. If you have any questions, ask it in the chat. And of course, feel free to continue to bemoan the choices made by the Singapore Math Society or of your brain this morning. Yes, more of you are talking about cutoffs again. If you came a bit later, what I said at the start, I have not had any immediate reason to change my mind yet on what I predicted the cutoffs are. But as I said at the start of this video, right, um, for the for this year's paper, it's not the very traditional SMO Junior, but the questions themselves are not difficult questions from the topics they belong to. So as we will continue to see, the problems themselves are fine if you are familiar with that topic. And so this is sort of indication to us to try to widen a little bit the range of topics that we cover in our own practice, in school, in classes, wherever we have some control, right? This goes both to from the teaching side as well as from the student side, the SMO participant side. I think it's a good thing from like the paper is interesting perspective. It's cool to have questions that are not just the same algebraic identities over and over again. But that does mean that it is something that you can't just figure out in the contest itself. That's really hard. Okay, so like this is something that I often share, but it's probably worth saying now anyway when many of you are in a slightly non-class mood. Even the divisibility test for 9, not all of you know why it's true, right? Many of you have heard it. In fact, some of you have not heard it, that is perfectly fine. Like, it's an Olympiad thing. I have friends in university who studied math that did not know the test for 9 because this is just, if someone has not told you, you don't know it exists. So some of these are just tricks. Like, not knowing it and other people knowing it because they've heard it before does not make you dumb. It just means that now you know. And the more time we spend in this, the more things we know. That's all. Speaking of tricks, the trick for question 10 that I like is what I call the pencil trick. But no one is going to see my pencil on the screen via YouTube, so I shall grab an arrow. I shall color the arrow red so that everyone can see the arrow. I shall also make a copy of the arrow so that everyone remembers how the arrow started when we first began. And what I'm going to do is just to start rotating. Now this is not necessary, but I think this is just cool enough to mention. I was talking about tricks. Here's a trick. You just start rotating according to each of the angles. So there was angle A, there was angle B, there was angle C, there's angle D, angle E, angle F, and angle G. Now we are back, but it's pointing the other way. Do you keep track of how many times you rotated? It's pointing the other way. So this is why I say a pencil trick. Now, please don't use a ruler. Then you don't know which way it was pointing at the start, right? That's why I have the arrowhead there. And so this is going to work. This is perfectly acceptable. But obviously, some of you will have reasonably said, don't need lah. This is just like such a silly question. Why do we need to do that? Yeah, I'm going to mention all the tricks I said at the start, all the different weird things we can do. Okay, so the traditional angle sum way of doing it is basically to say that these two here, I can just transfer it over to here that they will have the same sum. Not that the triangles are similar, not that they're congruent, but that they are both equal to 180 minus this. So if you transfer these ones over to there, and you add up all the rest of the angles, it becomes just the angle sum in a very oddly shaped pentagon. That's still 540 degrees. Okay, so if you are not convinced by rotating a pen, then do this. Another thing that we do need to persistently tell ourselves when we are doing these questions is the question is not impossible. You have to keep telling yourself that. Now, this is not an assessment of your math ability kind of the question is not impossible, but oh, I'm so lousy at math, so it's impossible for me. It's not impossible for my friend that's really smart. No, not that kind of thing. It's that they know you have no calculator. They know that you have 6 minutes per question. So you have to just have a bit of trust in the question setter. Yeah, yes, I know I've also said the SMO always makes mistakes in setting questions, but still have trust that they will get 23 to 24 or 25 questions correct, at least. So trust that the question is nice. Now, for something like this, sum of the digits, is there a formula for sum of digits? No. Then how? Just find a pattern. Powers of 10, okay, right? There's no calculation involved in powers of 10. Just write the correct number of zeros and you are fine. So this is 9900 minus 5 is like this. 6 zeros, so 1 million, 3 zeros, 1,000. You get 999,000 minus another 5. And it should be pretty clear what is happening, which is that you just add a couple of nines each time. It's just like your primary school Olympiad questions, except that you have to kind of fill in the pattern yourself. So the sum here is 13, and then each time you plus 2 more nines, which is plus 18. So 4225 minus 13, divide by 18. And so there are 200 and now this is also the place that I always get very scared. So make sure that you don't get off by 1. Dividing by 18, you get 234 is the number of times you added 18. And so you started from n equals to 1. So that means that your answer is not 234, your answer is 235. Question 12. Again, this is one of those questions that you could actually kind of list and check. Or rather, not really list and check, but you can list and then kind of guess. Because you know that the angles in regular polygons increase quite fast towards 180, and your two angles differing by 15 degrees, the gap becomes very small after a while. But if let's say that the smaller angle is more than 165 degrees, then game over, right? Because the bigger one cannot be more than 180. So technically, you can just list and check. But anyway, let's do the algebra, right? So the interior angles of regular polygons, we know that the angle sum is n minus 2 times 180 degrees n divided by n. This is your interior angle of your regular n-gon, n-sided polygon. But I think it is actually fun to just say the other side, which is that the sum of the exterior angles, because if I want to get the difference of interior angles, I can also talk about some difference in exterior angles. So the exterior angle is just going to be 360 degrees over n. Right, so by exterior angle, of course, it means that. The fun thing, by the way, about this is that you can also check the exterior angle by rotating your pen around a pentagon, although I don't think anyone is interested in that right now. And so if the number of sides differs by 25, basically one of them, if let's say I have n sides, n plus 25 sides, it's just 360 over n, 360 over n plus 25 differs by 15, and this will be more convenient. I can divide both sides by 360 first. 15 over 360 is 24. So 1 over 24, and then subtract the two fractions. Just normal common denominator for subtracting fractions when there's algebra, no change. So 25 over n plus 25 equals to 1 over 24. Cross multiply. And here, because it is actually in integers, right? The number of sides is an integer. You can just try to factorize it until you find two things that differ by 25, which you will eventually get to 15 times 40. If you don't guess it here, you will still need to factorize, and when you factorize it, you are still guessing. That's how factorization works, so there's no difference. Okay. So it's 15 and 40, and so your answer is sum of the number of sides. Okay. Question 13. Now this is actually pretty difficult again for SMO Junior Round 1. It also requires a little bit of faith again, like we had for some of the previous questions, and we will continue to need for one or two of the next few questions, that m and n cannot possibly be that huge that I need to calculate 7 to the power of some weird thing. But first, is 238 divisible by 7? Yes, it is. It's 7 times 2 times 17. Now, divisible by 2 is definitely fine. Divisible by 7, I just need to make sure they're positive integers, which they are. So that's also fine, which means that basically you only need to worry about 17. Now, in order to deal with 17, you basically need to just write down the sequence of remainders when 7 to the power of something is computed, is divided by 17. So I'll just write it as mod 17. We're not doing any modulo arithmetic here, right? We're just writing the list of remainders when powers of 7 are divided by 17. So start with 7. 7 squared is 49. So 49, you get a remainder of 15. If you're comfortable with modular arithmetic, just write minus 2, but I'm going to just avoid that. I will just use positive remainders. Okay, so times 7 is 105. Divide by 17, remainder is 3. And you basically go on until we can find a pair that adds up to a multiple of 17, which is probably 17 itself. How long is that going to take? Well, it can't take too long because they're only 1 to 16, and in fact, they come in pairs. So you know that the worst case scenario is not that bad. Okay, 4 times 7, 28. Remainder is 11. 11 times 7, 77. Remainder is 9. 9 times 7, 63. Remainder is 12. 12 times 7 is 84. That is sort of negative 1, but I will leave it at 16. One more is 10, and at this point 7 and 10 work. You can also kind of, for each of them, just write down what is their complement that will add up to 17 so that you know you won't miss anything, right? This is waiting for 2, 14, 13, 6, 8, 5, 1. So none of those have appeared yet, right? So we know that the first time it appears is this and this. That will be m equals to 1 and n equals to 9. So I like this question, right, for SMO Junior. Like it feels like an interesting question of appropriate difficulty, but when I say appropriate difficulty, it is not the median difficulty question in question 13, right? It is definitely harder than that. Okay. Question 14. There was the scary version of this in the senior paper, which if you guys were joining there, then you saw the one with the 11 over 3, 5 over 3 is a square root and whatever not. This is kind of like the friendly version of the same idea. that the question tells you it has a unique positive real solution. Now, we cannot actually solve most equations that look like that. Meaning that if I were to change this to 26, you can't solve it without a calculator, and in fact your calculator will not give you a nice value because there's no nice solution. So what is nice about 27 is that the answer is so guessable. 27 is itself 3 cubed. So clearly x cannot be itself a whole number, otherwise the left side will be big, the right side is a small fraction. So x is a fraction, and the only fractional power that looks nice is 1/3. So there is honestly, they already tell you it's a unique solution, so your job is to guess. Moreover, it is such that if they ask you for 2025x, you know that x is a nice fraction, so that 2025x is a whole number. Exploit that too. So the way to do is guess. Yes, the way to do it is to guess. It is not like as if I cannot do some other rearrangement first before you guess, but even after rearranging, you still have to guess. Question 15. This one doesn't look too original. I feel like we have seen it in one of the previous year's papers as well. I want to say 2019, but right now I'm a bit sleepy, so I'm probably misremembering the year. I also mistyped with extra x. It's possible to put it in and substitute x as the square root. But think about it. Which one do you hate more? The square root or the x? Now we are used to, if let's say that it was x equals to 1, please substitute in x equals to 1. But if x is this square root, no, I dislike the square root more than I dislike x. And so it actually makes more sense not to substitute x equals to this. It makes more sense to substitute 2026 square rooted equals to x minus 2 and substitute in x instead for every appearance of square root 2026. This is better than having the square root. So it's not always automatically that numbers are nicer, right? This is actually not too bad. Okay, so let's open everything up. X cubed minus x squared minus x cubed plus 2x squared minus 3x minus x plus 2. Okay, and so what has come of all of this? X cubes cancel off. You're left with x squared minus 4x plus 2. Do you want to now substitute it in? You can. Right? Just substitute it in if you want to. Alternatively, you can complete the square. And x minus 2 squared is 2026, so this is very nice. And not a single square root has appeared in our working down here, except for the fact that I've written square root 2026 as x minus 2. You have to trust the question setter. This is what I mean. Right? So like sometimes you're like, SMO is so hard. Oh my goodness, this is hopeless. And so in order to prove to the question setter, who does not even look at your working, by the way, or your question paper, that look at what torture you have put me through. You purposely kind of write such a long solution and then make such a huge mess, almost to kind of vent your frustration at someone who doesn't even know you're frustrated. Please don't do that. The expression is called cutting off your own nose to spite your own face. Trust that there is a nice solution, please. Trust that you do not need to list out a whole bunch of 4-digit square numbers until somehow it matches. The chance that you succeed is highly contingent on how well you can list square numbers without making mistakes, because if you make a mistake, you can't even find it. This is where being familiar with SMO folklore is very important. Almost every year of the SMO Junior, they find some way to ask a difference of squares question. And so the moment I see perfect square, I kind of trust that it's a difference of squares. which is exactly what it is, because you have got AB and CD. You plus 17 to the first two-digit block to get PQ. You plus 17 to get the second two-digit block RS. That simply is called adding the number 1717. That's what this is. So if I call this ABCD x squared and I call this y squared, we have just got the difference of squares is 1717, which is also quite possibly the most factorizable number ever because it is 17 times 100 plus 17. Okay, so straight away, we get this is 101 and 17 because clearly y plus x cannot be 1717 and y minus x be 1. So you solve y plus x and y minus x, you add them, you get 2y equals to 118. So y is 59, and then 101 minus 59, x is 42. Now, normally I would say, please check your answer by squaring them and seeing if it works. But the question asks you for the sum of the two perfect squares, so you still have to square them anyway and check whether it works. So this is kind of like a guaranteed to happen thing. Okay, so if you squared 42, you get 1764. If you squared 59, you would get 3481. Good, that works. If you got your two things that don't match, it just means that either you squared wrongly or you found x and y wrongly, but at least you kind of have assurance that this is definitely right, as long as you don't add wrongly at the end. Okay, so that is your sum. It is 5245. Okay, let's do one more question and then we will take our let's just do two more, I guess, before we take our second break. Okay, 17. Now, I'm going to sort of say this as preemptively because there are a few more geometry questions. Rule of thumb for SMO Junior, until they do something weird like they have done for like in the past long ago, but that's like 15 years ago when I was doing SMO Junior. There is no circle geometry, there is no trigonometry, there is no Siva and Menelau's theorem, so the only options you really have are standard area formulas, standard angle properties, which you will not forget those. But the ones you forget, similar triangles. It's always similar triangles. Whenever there is a parallel line, there will be similar triangles, right? I think I have said in various places about the two common patterns with parallel lines, which is this pyramid pattern and this hourglass pattern. Now, this is not that the pattern is why they are similar, because if let's say that you draw this and then I draw this line here, this is still looks like a pyramid, but that's not similar anymore. The reason is corresponding angles here and alternate angles there. So therefore, the two triangles have all the same angles, therefore they're similar. You always want to use similar triangles, especially when you see things like a ratio that is otherwise quite useless. Right, this is 4:1. So, how do I use that? Well, the thing about this is that your two parallel lines currently don't really have much similar triangle action going on because there is no line that reaches from one side to the other side. And so what you can potentially try to do is to extend something like that out. But of course, whether you want to extend it here, do you want to say extend it down here? Oops. All this is up to you, and I'm not going to actually make up my mind until I have gotten this area ratio to do something first. But those are the kinds of things that I will do with parallel lines, right? Similar triangles. Okay, so they've given me this area ratio, APD and APB. How do I find the area of APB? That's pretty simple because this is 10. So actually I kind of want the height. If I knew this height, then that would be the area of APD, sorry, of APB sorted. Then what do I do with APD? Now that doesn't have a nice base or height. Well, I can actually add a parallel line here. Now if I add the parallel line here, what does it do? It will do two things. The first is that this height can be multi-purpose. And the second is that it actually shows you how these things are related to each other in terms of their heights as well. Because if this is 4:1, the similar triangles that I can care about are actually kind of like, for example, here I can say that it means that this height is also going to be 4 times of that height. So I can call this 4h and h. It also means that the length as you move down from AB to CD is increasing at sort of a steady rate. And so I can say that if this is sort of like reached, let's say 10 plus 4x, then this would be 10 plus 5x, right? Because this is increasing as you go down. Now this, if you realize, is, I'm not really using this pattern, right? Yeah, in a way I am not, because that pattern is just still intuition that if you have these kinds of parallel lines, the distances are just increasing steadily and in that fixed ratio. Therefore, now that I have this, I can just form the equation and everything should be fine. And the original line that we draw, not necessary yet, but trust me, we will need that on some later questions. APD has got two parts. The top half and the bottom half, but they both have the same base, so I can actually just lump that into 5h. The bottom part is just APB is half times 10 times 4h. Okay, so this is pretty easy to just simplify all over the place. Okay, and you will get x equals to 5. So CD will be 35. Okay, we'll do one more before we take our second break. X cubed plus 4x equals to 8. Find the value of x to the 7 plus 64x squared. Many of your teachers, including me, have mentioned the long division method. Remember, question setter is sane. Question setter is not mad. Question setter, despite sometimes making mistakes, is still trying to be nice to you. Um, they are not going to make you waste time with long division of power 7. Even though your work, power 7 divided by a cubic, that's just horrible. It's always important to realize that there can be more than one method, and depending on which of them, depending on the numbers you have, your choice is different. If let's say that you want to go from Pasir Ris to Tampines, right, you can take a bus or you can take a train. If you want to go from Pasir Ris to China, you are not going to take a train. You take a plane. But that does not mean taking a plane is always better, because would you like to take an aeroplane from Pasir Ris to Tampines? No. All of that is to say that in this case, we need to take an aeroplane to kind of jump from 3 to 7 as quickly as we can. And so what I'm going to do is I will take this and use it as an identity, and I'm going to try and shoot to, well, the closest I can get to is by squaring it, I can get to 6. You want to take the biggest jump you can to get as close as you can, but 7's weird. So we will just hit there. Okay, so you got 6. Now it's sort of like you took the flight to China, but then you're like, okay, you landed off Beijing, but you want to go to Shanghai. So how? Take a domestic flight. Right? My geography is bad. You would just go straight to Shanghai, right? Some small town near to Beijing, then you would take a flight. So domestic flight here is now just multiply by x to get x to the 7. And so magic happens. X to the 7 plus 64x squared, which is what you want, has shown up. And this is just 16 times of that. Now, if you're like, how am I supposed to know this will work? Because it's the SMO. X is not nice. If they just put some random numbers there, power 7, some square, it will also not be nice. So you have to trust that the numbers are carefully chosen. Which in this case, they clearly are. Okay, now we will take our second break. Time for you to vent frustrations, ask questions. I've already talked about the cutoff, right? So I'm not going to say more about the cutoff again. And of course, if any of you are taking open tomorrow, all the best. I'll just say that for anyone who's doing junior and open, the best strategy, unless you are like you're doing junior open and you think you can get like nearly full marks for this junior paper, please, when you're doing the open, be ready to look at the whole paper, skip a lot of things, but like try to find 10 questions that you think you can do, and then just focus on those 10 first. You can do with some probability, right? That's what you should do first. Don't go in order, because the question 1 may be the easiest one if you know calculus. Question 2 is the easiest one if you know complex numbers, and that does not apply to many of you here. Okay, so we'll be back in 5 minutes. Leave any questions you may have in the chat. Has anyone changed their mind on how difficult the paper is after the as of about 2/3 of the way through? Uh, I would suspect that many of you still have the same opinions you held. If you thought it was easy, you still think it's easy. If you thought it was average, you think it's average. If you thought it was very hard, you still think it's very hard. And so, like I mentioned at the start of this one, I think most of you will have uh, the same kind of opinion from wherever you started. Uh, yeah, so we will see how the cutoffs are like because it depends a lot on the number of people who get in. I mean, my thoughts, I said 13 to 14 if you are going with the 120, 130 people because there are probably 30, 40 people who will score extremely high, but that's not going to swing the cutoff. But if it's like they suddenly decide to allow, I don't know, like much fewer people, then we will never know. So this is up to the Singapore Math Society as always, and we shall see. Okay, so final set of 7 questions. Here we go. But before we go through the questions, I would say that the paper is not that bad from the perspective of tediousness. 2.5 hours is enough time to think. So you should definitely not like pick a question and decide to list a super long list or do a super expensive and messy calculation. But at the end, you probably have time to like do those messy things for like 2 or 3 questions. So that is the setup, I think, for this paper. It's not that time consuming, so you can afford to have very messy methods for a few questions. Okay, 19. How many ways can 4 boys and 3 girls stand in a line such that every boy is adjacent to at least 1 girl? This is precisely the kind of situation where I said listing, right? You can list out in some sense the positions that the girls can take, but do it in the most intuitive way possible, which is that if let's say that you want to, I'll kind of just draw like a box of with like 7 okay positions, and then you just systematically go through and just tick all the possible positions that like 3 girls could be occupying, such that that every boy is adjacent to at least 1 girl. So this will be the first one. Essentially, at the corner, there can at most be 1 empty one. You cannot have 2 corner empty in a row, and in the middle, you cannot have 3 empty in a row. So that's like all that we are doing. And this is pretty boring, but not hard. Now, is there some sort of other cleverer method to do it? Yes, but thinking of the cleverer method will not be faster already because this is not taking that long. I've missed one, haven't I? Can you see where I've missed one? Yeah, this can also be here. And this is the thing about listing. Make sure that you check your list a couple of times. And also make use of things like symmetry to check. So for example, I knew that it should be, there are 3 of them that have something here. There should be 3 of them that have something here because it is symmetric. Okay, so this is just saying that there are 8 choices for where the girls go. These are the positions taken by the girls. And then 4 factorial, 3 factorial, once you have decided where the boys and girls go, then just arrange them among themselves. 20. Trapezium number 2. Make sure that you read the question because numerical information is there, but just as importantly, the angle bisector information is there. The most important thing when it comes to a lot of these geometry questions is to figure out what to do with the most annoying feature. Now, if the most annoying feature is like a very computational thing, like, oh, I just need to do all this algebra, then fine, we do all the algebra. We did that for question 17. If the most annoying feature, however, is that I cannot figure out what to do with the angle bisector, let's say, your response should not be, yeah, I'll ignore it. Your response should never be to ignore the most annoying feature. Your response should be more to say that I'm not going to move on until I can think of one good way to use it. There's at least two reasonable ways to use it, both using the fact that when you've got angle bisectors, you want to make that equal angle meaningful. One way is that you can now do the thing that I said just now. Now that is useful here because if you were to move this over here, then you will end up with an isosceles triangle, right, by your alternate angles. This can work, but I think there is something else that may be a bit nicer, which is just that angle bisectors also can be thought of as just lines of symmetry. Anytime you see bisector, it's a line of symmetry. Perpendicular bisector is a line of symmetry between 2 points. Angle bisector is a line of symmetry between 2 lines. Therefore, I can just reflect this over. I'll note the right angles, but basically this thing, if I just reflect it over, you almost get the area. Except that there is a little bit that is actually not wanted. You don't want this portion. However, that's easy enough to resolve because of now that pyramid pattern in your similar triangles. So if I call this point F, you know that the area of CDF is 2 times 16 is 32. This is then followed by the fact that FAB, this is 1:4. So it's 32 times 1/4 squared because the ratio of your areas is the square of the ratio of the side lengths. And so your answer is just 30. Which is, these are exactly the kind of problems why I say this is a hard paper and an easy paper at the same time, right? You can agree to disagree because this is a common trick and yet it's not obvious if you haven't done a lot of geometry. But angle bisectors, apart from the angle bisector theorem, which some of you are aware of, don't forget it is always a line of symmetry. 21. A set of 6 whole numbers, exactly 3 of which are prime, not necessarily distinct. Okay. I thought about this in the morning a bit. So isn't a set supposed to have distinct things? Well, there are such things as multi-sets. So we take it as this is actually just a collection of numbers. Because for mean, median, mode questions, if they're all distinct, mode doesn't make sense. So we take it as just when they say set, they're referring in the multi-set sense. Right? Exactly 3 of which are prime, not necessarily distinct, means that 3 out of the 6, not 3 different prime numbers. Okay, the rest of this is now like a puzzle. Mean is 16. We can get the sum. Median is 16.5. Now that's interesting because it means that these two sum to 33. Right? Median is the average of the two middle numbers if there's an even length list. But I can't skip 17, so which means that 16, 17 is the only choice, because if anything else that I pick, 17 has just fallen into this chasm in between, never to be seen again. So that is definitely not the mode, because the mode is the one that appears the most often, and the unique mode means that it uniquely appears the most often. So definitely 16 and 17. And 17 has to appear at least one more time. Okay, so that is going to have settled my median and kind of settled my mode, as long as I don't forget to not let other numbers repeat. Okay, so at this point, I am left with 46 for the other three numbers. Well, I need to check, can 17 appear 3 times first? So I'll check that. 17, 3, because the range is 14. Nope, if it's 17 and 3, then the other one here would be 26, which is not in the correct order anymore. So 17 only appears twice. That means there's no more repeats, and essentially I can just go with this is n, this is n plus 14. Make sure there's no repeats, but now that I know there's no repeats, there's no other information I'm going to take from the mode. N plus 14, and the remaining is 46. So 46 minus this is 32 minus 2n. Now that they say exactly 3 of them are prime, I want to list n, but I need to know what to check. So the thing to check is listing out and seeing 3 of them are prime. There are 2 primes here. This is definitely not going to be prime because it's even. So it means that exactly one of these 2 things need to be prime. So n should be an odd number, and you can just kind of test it out. Okay, so 32 minus 2n also has to be at most this. So n is at least 8, or rather more than 8, because there are no more repeats. So we can try 9 next. Oh, right, that works already, doesn't it? Okay, for sanity's sake, sanity check, if you just sort of tried something else like 11, then this one is already going to be 10. This is already the wrong way. So there's actually nothing else to check. I don't like that they ask for the sum of squares. But when I see that, I will just double check my calculations to make sure that I don't mess up, because this is a very annoying way to fail. So fast forwarding all of the calculations, of course, but you definitely would want to double check this computation. Double check how, again, use the last digit, let's say, to check at the end, and check things like, is this like absurdly big, absurdly small, apart from, just calculating them again. Okay, this is the typical mean median mode question from the SMO junior. So it is always used in some kind of puzzle manner, because asking you to find mean, median, and mode of a list of numbers, there aren't too many ways to do it in a fun or interesting way. Okay. #22. Another geometry. This is, first of all, it's important to note that the semicircle is mostly unimportant, except for the fact that, yeah, you know that these are equal. It does not require us to use even our Thales theorem for like right angles in the semicircle. You don't even need that. This is 40. QP to PC is 3 over 5, so I can call this 3x, 5x. 5x. 3x, 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 5x. And then at this point, you may feel a little bit stuck. Well, if you are feeling a bit stuck, ask yourself what information you have not used yet. And that is not always just going to be a numerical thing. Basically, you have not used the fact that P is on the semicircle until you draw this line in. And as a general rule of thumb, when you see a center of a circle, you do usually want to connect it to other stuff, right? Because that is how you can use the fact that it is on the circle. It has an equal distance, which is the radius, to the center. Now, this two then are going to be very obvious congruent triangles, right? Just the side congruency, or you can even just say that it's symmetric. This means that since I'm dealing with areas, I'm going to talk about ratio of areas. This is 3x, this is 5x. I just called it that. I can change this later. But the 3:5 ratio means that this portion to this portion is in that 3:5 ratio, which means that the area is 3:3:2. That still doesn't help me to find the area, but it helps me to find something else surprisingly, which is that, and so now that this is 2 and 3, this is 2:3. And so I've found using area, not the area, I've actually found the length of the radius, which is 60. And all of them are therefore 60. Okay, so that's useful. But now I'm going to just erase away this 3a, 3a2 because I don't want to artificially have too many variables inside. I look at this and I realize that to find AOQ, this A is actually been just sitting there doing nothing. It's kind of irrelevant because the area of AOQ is the area of OBQ. Right? And the area of OBQ is such that therefore I can, in a sense, ignore everything that is on this side. They no longer matter. And in fact, therefore, the semicircle doesn't matter at all. And I can just draw this triangle and now ask myself, okay, what do I have left? This is a trick that I like to use for geometry questions. It's just like, you know, when we do elimination for our simultaneous equations, you want to get rid of some variable. I want to get rid of points. If they have no point in existing, then let's make it no point. In fact, now we can say that for this, if you know Stewart's theorem, you can use Stewart's theorem. If you know power of a point from your circle geometry, you can use that. But for junior level, it's Pythagoras is enough. Cosine rule also can work, so like you have a lot of choices, but I am just going to split this up. Call this height h, 3x, actually I don't need to call this 3x, I can just change it to 6x, so they're all integer, 6, 6, and 10. And then now we have got our Pythagoras on the two triangles. Okay, so just subtract x squared will be equal to 40 non-integer, so that means that this was probably not possible to, like, you know, just guess out that easily. And you can put that in. H squared is 3240. And what do you want to get? I want OBQ. OBQ is 3/5 of OQC, which is just the whole triangle that we have been working with now. Half times height times 16x. So you get 24/5 hx. Okay, so I don't need x or h, I just need x times h. I can multiply this together. If you grab the two zeros at the end, and then 4 is 2 squared, 3 to 4 is 18 squared, you will get this is 360 squared. So bit more calculation involved in this one. You may have a different geometric method, and especially if you know your power of a point / your circle geometry, it will shorten it a lot. I'm just presenting one that fully uses junior level tools only. Please feel free, however, to unleash all the tools that you know. So seeing as, like, let's say you are confronted with a bunch of questions like that seem that I did not expect probability to be asked like this. I did not expect them to ask this kind of like factorization identities. There's no harm also in just taking a look at some of like the senior level content as well, even if you're doing junior, and just learning it anyway, because it is often like just a few extra formulas. No harm in knowing them. Okay, 23. Okay, this is one where if you, there's kind of two things that can happen. One is that you just factorize this and then you got stuck because you somehow just assume everything had to be positive integers and you're very confused. The other thing that could go wrong is that you kind of used the wrong negative and then you just thought that you misunderstood and moved on. It's also possible, however, that you just landed on the correct thing and don't see what's the big fuss of this question. But in all of those paths, integer, integer, so we are going to start from factorizing 1183. We know that we have to factorize 1183. There is clearly no way around it. But I see so many factors, so I suspect it's not that hard to factorize. You try 2, 3, 5, no, but 7 works. You divide, you get 169, which is 13 squared. Okay, so we wonder then, how do I split it up into so many parts? Then you realize that you actually can have some buffer room, because I can use 1 and minus 1. I can use 13 and minus 13. And then once you realize that, then you are fine, right? The last one here, you just put in a 7. Order doesn't matter, so it's up to us. But now if I add up all of these things, yeah, because they're distinct, so therefore I can't just repeat 1, 1, 1 or something. So that's why I know it looks like that. You just add, you get 5b minus the sum is equal to 7. Then you'll be fine, right? Because you get 5b equals to 30, b equals to 6. Now, some of these questions, I feel like as if I get deja vu when I see them, because they are ideas that I think last appeared like in the years when I was taking SMO Junior and a student, 2008, 2009, 2010, like those are the kind of years. if you're watching this now in 2026 and tomorrow is the SMO Junior 2026, there is nothing you can do. But if you are watching this now and you can take Junior again next year, over the next 12 months, I know that it sounds like teacher talk, but really, I mean, that trying some of those old questions all the way back to like the mid 2000s can be quite fun. If you don't do it as cramming for SMO Junior, but say, okay, every few weeks I will do like one set of questions. Or even every week I'll just do one third of a paper or something. And then you will start to find that actually, this is quite familiar, but it's familiar from quite a long time ago. Was this from last year's Open Tour? Yeah, now I remember, right? Yeah, I feel like I've seen this. Okay, 24. Notationally, and I think this is about the time to kind of bring it up. A1, A2, A3, A4, this kind of thing, like it just tends to scare us a little bit, right? Uh, Please understand that subscripts, like whether it be here A1 to A5 or here another A1 to A5, subscripts are just there because you're trying to say that these are just different variables, but they're kind of the same category, and so I just call them A1 to A5. If you do any coding, it's like an array. It doesn't have any meaning like indices, right? A1 to A5 is just like five different things which I all call A, which is better than you can say, I'm going to call it A, B, C, D, E, F, G, and then what happens if you have more than 26 variables, you run out of letters of the alphabet, and then you start using Chinese characters, jia, yi, ping, ting. No, right? We use subscripts for this. You want to just be able to summarize the question, and this is actually a very simple thing once you summarized it. The absolute value of ai minus aj is greater than or equals to 2 for all ij equals to 1 to 5 and ai not equals to j. A1 to A5 is everything. Absolute value of something minus something is the difference. It's just telling you that any two digits differ by at least 2. That's all it's saying. Hang on a second. What digits I have? 0, 1, 2, 3. There's only 10 digits. If any two of them differ by at least 2, list lor. Because how long is that list going to be? Not very. This is once again probably the fourth or fifth time where some of you are annoyed by what I list again. It's not list the numbers, it's list the cases. So please make the distinction. Right? It's just 0, 2, 4, 6, 8. 0, 2, 4, 6, 9. Now you can technically go and use the partitioning method, your stars and bars, but this is like too simple of a case where I don't really want to bring that up right now. It's not necessary. You just have this as your possible list, right? It's just kind of like 0, 2, 4, 6, 8. I only have one buffer spot, and then I can just sort of slide them over one at a time because the gap must be at least 2. Don't forget the first digit cannot be 0. So for these cases, you have 5 cases where the first digit, there's 4 choices, and then 4 factorial. But this one is just plain 5 factorial because there's no 0 issue. Okay, so 600 numbers. Actually, I don't know why is the review shorter. I think we all agree the paper is not that like it's not full of easy questions compared to last year, right? I mean, why is it that we have only spent 1 hour 15? I don't know. Maybe I was very long-winded last time, but you can see that time is sufficient in terms of like 2.5 hours because I am talking all kinds of tangents and side notes which you obviously will not be. So time is really enough. You have time to think. For the SMO Junior, you have time to think. So when I say list, it's not because I have nothing better to do. List because the list is not long. And you actually know the list is not long, therefore I'm not afraid to do it. We're at the last question. And this last question is kind of also symptomatic of this whole paper. You can have so many different loopholes and tricks and gimmicks for a big chunk of it. Only these last few questions didn't have those loopholes and gimmicks, but this one, they told you nothing about the triangle. You can assume it's equilateral, you can assume it's right angle, you can assume whatever you want. There is actually nothing stopping you from that assumption. So when I saw this question, the first thing that I did was just draw an equilateral triangle. That doesn't look equilateral. A median, of course, just refers to this being the midpoint. This is the geometry median, not the mean median, mode median. And then I just assume that, oh, okay, it's just line of symmetry, yay. G is anywhere. I assume that it's just in the middle, yay. And then I just draw a horizontal line across, yay. And then I'm like, okay, this is 2, this is 2, this is 2, so k is 2. There's no way that this is wrong, because the question is kind of implying to us that it doesn't matter how you draw the triangle. This is question 25, right? So you want to scold whoever you believe to be the SMO coordinator for the junior section, you can feel free to mentally express your frustration. But it's actually kind of like a nice property, and so I'm just going to talk through the solution. So please stay for a few minutes, right, before we end, just to talk about the solution, which is that when you see all these ratios here, I can think of this as a round 2 question too. It's a nice round 2 question. By the way, we're talking about round 2 here. If you think that you have a good chance of qualifying, please start looking at the round 2 questions. If you think that you only have a 50% chance of qualifying, look at them anyway, because they're quite interesting. And if you think you have no chance of qualifying, still look at them anyway. Like, round 2 questions are interesting. You just need to be, like in a school holiday, you can kind of just take one interesting question and say that, okay, I'm going to just like think about it like for a few minutes, and I go and do something else, and then later I'll think for it for a few minutes, do something else, and then, okay, fine, I'll read the solution, I give up. That's how you want to do it. You don't want to do it when you have a pile of holiday homework. You still have a pile of holiday homework, don't you? But you don't have to do it today. For round 2, this is the kind of thing that you would do. If the question were formed in this way, you would still assume a special case to get the answer. That's how you have to approach things. Try special cases, but then when you want to go and prove it, ask yourself, okay, where do these kind of ratios normally come from? And the answer is similar triangles. For a proof, I cannot assume that this is having any similar triangles. I can't assume that this is parallel, because clearly it doesn't have to be. And so the easiest way that I can get those ratios is to just draw one more parallel line on top. However, let me just do a little bit of realignment, because this is not very conveniently located for what I want to draw. So let me move it away so that I have more space. Okay, we'll get back to the question's expression later. I want to draw a long horizontal line that is parallel to the one below. And the reason why it needs to be so long is because I would like to be able to extend it across here. And also down the other way. Now, this will actually remind some of you of certain old SMO questions where this was already drawn in. And this is why sometimes the practice also helps. Like, you know, we actually kind of say, hey, wait, I feel like this is just that old question with one line removed. Put it in, extend stuff, and then now every of those ratios can be handled using your similar triangles. So CA over CE, this was the first ratio. CA is more than CE. CE is part of CA. So I can chop it open like this and use my parallel lines for the ratio. This is similar triangle pair number 1. pyramid pattern or hourglass pattern, right? This is a very mutated hourglass. EA to CE will run to AY over CX. Now, why is this even of any use? Because we're going to do the same thing 2 more times. CB over CF is 1 plus BF over CF. That is going to be this hourglass. So it's almost the same, which is the whole point, because I have stuff that are all very closely related to each other. And to nobody's surprise, the third one will also be roughly the same. That 1 plus dy over cx. Now, if I take the left-hand side, which is these two, and add them up, you realize that the only way that this could possibly be related nicely is that it is 2 times. And it turns out to be yes, because the average of AY and BY is going to be dy. Since these two are equal, the average of those two is this. And so therefore, this will be just clearly 2 times of that. Therefore, k equals to 2. So this is one possible way to prove it. However, as a round 1 question, you would have been done about 7 minutes ago because you could just assume a special case. Yeah, and that brings us to the end of this review. We are at the end, just a touch after 9 o'clock, which is nice. I don't know whether you still think that the cutoff, like what I estimated at the start, is reasonable. I did say that my predicted cutoff for round 2 is 13 or 14 because of that is where I would draw the line of, let's say, the top 120 students, not the top 30 to 40 who I think may be able to score very well. If you are talking to your friends and most of them are hoping to be in the top 30, whatever they're telling you has nothing to do with the cutoff. And of course, if you're talking to your friends who are hoping to just get an honorable mention, that also does not have anything to do with the round 2 cutoff, but that will have much to do with the honorable mention cutoff. So I do think that the cutoff for the silver, bronze, and honorable mention will not be that high because for the majority of students, they may find it unusual. However, of course, they don't really disclose how many percent get this. So if it turns out to be the cutoff is higher because they gave fewer of these awards, then there's nothing we can do. Okay, so we are essentially done. I'll leave the chat open for a while. I'll stick around for a few minutes to answer questions. If you are taking the SMO Open tomorrow, again, all the best. Please don't spend the next 3 hours watching the open review. Have enough sleep because that is what you need before tomorrow. Okay, so thanks for joining, and yeah, just feel free to mention anything that you want to clarify in the chat. Yeah, so top 30, I feel like there could be 30 people who would have scored like 20. Of course, top 30 depends on round 2, but I can feel that like there could be 30 or 40 students that scored above 20. It's possible. Again, you guys know better than me, especially if you have talked to more of your friends, right? Like I have to trust the chat, right? And I know that some of you are trolling me. So like from a teacher perspective, there is no way for me to know the difference between 30 students got 20 something and 50 students got 20 something. I cannot tell the difference, right? I can just say that it's quite possible. Does not mean I know how many. But if you're talking about, let's say, for anyone who is hoping to get into round two or get some of the other awards, it's not going to be nearly that high because if we are looking at the previous year's papers, this one is definitely going to look a bit more unusual to the majority of us. For we'll see, right? So if some of you have a sense that it may be higher, maybe my estimate is off, we will see. I am not claiming that it's definitely right. For round two preparation, just I guess if you have access to the past papers and you have not tried the questions, do try them. But if you are very new to it, do read the solutions after like trying for a little while. It's okay. There are more than enough questions to last you because when I took the SMO round two, first there were only two past year round two, so I had a problem that I ran out of problems. For you guys, if you do the look at the last 5 years ones and you sort of just use the questions just for reading examples, you still have lots to go. Round one, yeah, so like I guess I will like film a video at some point after the SMO round one has cooled off a bit, just talking about resources and all. But for practice wise, the AMCs, the American Math Contest, those are the most easily accessible ones. So those are going to be useful questions for getting used to some of these problem types. In terms of like SMO specific resources, clearly the SMO changes enough from year to year that like there is no such thing as a SMO specific resource anymore. But we can say that apart from the past year papers, like if you can find any Olympiad textbook that you feel is like you understand it well, but you can do something about 50% of the questions, that's good, right? And there are many different sources for that. So like I said, I'll probably record some videos on this later, not later today, but sometime after the round one. For geometry questions, yeah, the thing is that geometry, getting good in geometry in general, and getting good in geometry for junior is quite different. For junior, you want to recognize a few of these patterns a lot because a lot of them are always going to be similar triangles, Pythagoras, congruent triangles, symmetry. There is a limited scope of things. But like I said, if you want to, you can start learning some circle geometry, trigonometry as a backup. Because many of these questions, if you know your trigonometry tools, your sine rule, cosine rule, you have an alternative, which I did not present here. Senior wise, yeah, if you guys are doing year two and you sec two and you're doing senior next year, start by just literally looking at the senior papers like from this year, last year as sort of like a preview. I always like to think of this as like it's a good thing to have a preview. Not that I expect to solve much. Although it's a morale booster if you can solve a non-zero number of questions. So that you have some sense of what's going on. And then like if let's say you feel that, oh, I would like to learn trigonometry first, then learn that. If you would like to learn circle geometry first, learn that. And there's some of those fixed algebra topics which you want to know, like all your O-level style math content, you would need to know that, right? So you can sort of do that first before going to the Olympiad type questions. You can just take a look at all those first. So any O-level textbook will cover the algebra portion. Combi geom and number theory is all over the place lah. So that one, actually, you can do quite a large percentage of, let's say, the combi geom and number theory for senior compared to algebra, because some of them don't use more high-powered tools. So you can look at those as well for trying straight away. Yeah, okay, so I think I'll go off camera first. Yeah, I'll leave the chat open for a few minutes just for you guys to, well, chat. But thanks for joining again. Good night. And yeah, just if after this you want to ask anything, just leave it in the comment section.